Good day everyone, my name is Daishan. Today I will present my project titled Predicting Financial Distress Using Machine Learning Approach. The purpose of this study is to develop an early warning model that can identify companies that are likely to face bankrupt by using machine learning technique. After introducing my topic, I would like to give an overview of this study. Financial distress prediction is an important issue in business and finance because companies usually experience warning signs before they are actually become bankrupt. If this warning sign can given detect early, stakeholders such as investor, creditor, banks, auditor, regulator, and company management can take preventive action to reduce financial losses and make a better decision. The main objective of this research is to develop an early warning prediction model by using a machine learning technique and financial statement indicator. Instead of waiting until a company fails, this model aims to identify companies that are at higher risk of financial distress in advance. For this study, I used the Taiwan Company Bankrupt Prediction Dataset, which contains 6,890 company observations and 95 financial predictor variables. Among these observations, only 220 companies are classified as bankrupt. The remaining companies are non-bankrupt. This creates a significant challenge known as class imbalance, where the number of healthy companies is much larger than the number of bankrupt companies. Therefore, in this research, I compared different machine learning algorithms to identify which model performed the best for bankrupt prediction. After evaluating their performance using multiple metrics, XGBoost was selected as the final model because it provides the best overall balance between prediction accuracy and the ability to detect bankrupt company. Overall, this study demonstrates how machine learning can be used and effective early warning system to support financial risk management and better business decision making. The main business issue in this research is financial distress can lead to bankrupt, liquidation, and significant loss. Thus, modeling issues are traditional methods often cannot capture complex relationships among financial indicators. Since bankrupt companies are rare, accuracy alone is misleading. So additional elevation metrics are needed. The main challenge is the model must detect bankrupt firms without creating too many false alarms. There are three research objectives, which are to apply machine learning models. Second, evaluate models using accuracy, precision, recall, XUAN score, and confusion metric. Third is recommend the best model as an early warning dashboard tool. Besides objectives, three research questions also been created, which are how do the ad model performs, which model performs best across the main metrics, and how can select models support monitoring and early warning decisions. The dataset contains 6,890 observations, which 220 companies are bankrupt and 6,599 are non-bankrupt companies. This giving about a 30:1 imbalance ratio. Thus, special techniques are therefore necessary. Graph on right side clearly shows house imbalance of this dataset. In methodology part, I follow a systematic machine learning pipeline to ensure every model was compared fairly. First, perform data cleaning and explanation data analysis to understand the data set and identify issues. Next, I divide data into training and testing steps using stratified stamping so both sites maintain the same proportion of bankrupt and non-bankrupt companies. Because the data sets were highly imbalanced, I applied smooth only to the training data to generate the systemic minority sample. This avoids data leakage while helping the model learn bankrupt patterns. Future scaling was applied for sales-sensitive algorithms such as SVM and KNN. After that, I used Stratified 5-clock cross-validation together with random search CV for hypermeter turning. Finally, the optimized model will evaluate on the original unseen test set to measure real predictive performance. After that, add algorithms which are logistic precision, decision tree, random forest, support virtual machine, k-nearest neighbor, graded boosting, artificial neural network, and XGBoost were compared. Every model used the same dataset and evaluation framework. It did not rely only on accuracy because the data are imbalanced. Precision measure how many predicted bankrupt firms are truly bankrupt. Recall measure how many actual bankrupt firms are detected, F1 score balance precision and recall, and the confusion matrix append the true positive, false positive, true negative, and false negative. Therefore, recall and F1 score are particularly important. In discussion part, we discuss add model performance under same method. This means that all models under the same dataset, pre-processing procedure, and evaluation metrics ensuring a fair comparison. The results show that not single model is perfect because each algorithm has its own strengths and weaknesses. Some models achieve relatively high overall accuracy but were less effective at identifying bankrupt companies, which is actually the most important objective of this research. After comparing all ad models, XGBoost achieved the best overall performance. It not only maintained a high level of accuracy but also obtained the highest F1 score for the bankrupt class, meaning it achieved a better balance between detecting financially distressed companies and minimizing false alarm. Another advantage of XGBoost is that there is an assembling boosting algorithm instead of relying on a single decision tree. It builds multiple trees sequentially where each new tree learns from the mistake of the previous one. This enables the model to capture complex and nonlinear relationships among financial indicators, making it more suitable for bankrupt prediction. Therefore, based on the overall evaluation result, XGBoost was selected as the final model and used for the subsequent analysis and the development of the early warning dashboard. The confusion metric demonstrates the practical trade-off. XGBoost correctly detected 25 out of 44 bankrupt companies but missed 19. It also incorrectly classified 25 healthy companies as bankrupt, while correctly identified 1,295 healthy companies. Increasing detection usually increases false alarm, so the goal is to achieve a balance that is useful for investor, creditor, auditor, regulator, and management. Future importance: analysts identify continuous interest rate after tax, total debt to total net worth, borrowing dependency, retained earnings to total asset, and liability to equity as the most influenced variables. These findings indicate that the high debt pressure, borrowing dependence, and weak retained earnings are strong warning signals of financial distress. The selected models can be transformed into an early warning dashboard. Companies can be classified into high-risk, medium-risk, and low-risk categories. The dashboard can display to top high-risk firms, important financial indicators, and suggest action. Investors can avoid risky investment, banks can strengthen credit assessment, auditors can focus on high-risk firms, and management can reduce debt and improve cash flow. The dashboard supports but does not replace expert judgment. This research demonstrates that machine learning can effectively support financial distress prediction. Among the 8 models, XGBoost achieved the best overall balance and was selected as the final model. However, the study is limited to Taiwan data from 1999 until 2009 years, excludes qualitative and macroeconomic variables, and still miss some bankrupt firms. Future studies should use narrow datasets, incorporate additional variables, and develop a real-time interactive dashboard. Machine learning should support rather than replace the expert financial judgment. That's all from me. I hope this can help you more understanding this topic.